Hello, everyone. Are you having a good snow day? I hope so. I'm sorry that I couldn't see you guys today, but the weather was not being cooperative. So I am just going to erase this really quick. It's my second attempt at recording this video. I'm going to we're going to do a quick review of what we learned last week, but also learn a little bit of new things. And I think you're going to actually like what we learned new today. It's going to help you graph things a lot more quickly. All right, so last week we were learning how to graph linear equations. And we learned that I could put something into this machine as an x value, and I would get something else out as a y value. So for example, if I put a 0 in for x, I love putting zeros in for x, that would be 0 plus 5, and I would get a 5 out for y. And we made our little graph over here, and we said if we put a 0 in for x, we got a 5 out for y. Okay. Then if we put something different in for x, let's put in 1 for x, we would get a y of 4. If I put let's put a 2 in for x. A 2 in for x, I would get a y of 3. Okay, so I would just take these 3 points, put them on my graph. When x is 0, y is 5. So here's where x is 0. Now let's go 1, 2, 3, 4, 5. Whee! Oh, come on. Whee! When x is 1, y is going to be 4. And when x is 2, y is going to be 3. Love it. Let's leave that right here. We're going to come back to that. Okay? All right, let's do one more. Y equals 2x minus 8. We're going to change this to, plus a negative 8. And you'll figure out why I'm doing this in a minute. That's terrible. Try again, Lorena. Plus a negative. Okay. Still terrible, but fine. All right, so we make our function machine. And when we put a 0 in for x, we're going to get 2 times 0 plus a negative 8. We get a negative 8. And when I put a 1 in for x, 2 times 1 plus a negative 8, I get a negative 6. And let's keep going. Let's put a number 2. When I put a 2 in for x, that's going to be 4 plus a negative 8. I get a negative 4. All right, so let's graph these. When x is 0, y is negative 8. I think that's 8 down there. Let me check. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. When x is 1, y is negative 6. And when x is 2, y is negative 4. All right, not too bad. Okay, so last week we did this a lot. We did it in class, and then you guys did it for your coursework. Did you notice anything? When you were working with equations that said y equals something x plus something, it could be whatever. It could be 12x minus 5. It could be 1/2 x plus 3, whatever it is. When it was in the form y equals something x plus something, did you notice something? Hopefully, you did a whole bunch of them, and maybe you noticed something, maybe you didn't. It's fine if you didn't. We're going to notice it today, okay? I want to show you why this setup, y equals something x plus something, is called our slope intercept format. This equation has a special name. Y equals something x plus something. Y equals -1x plus 5. Y equals 2x plus a -8. Y equals -4x plus 2. Y equals 3x plus a -6. All of these are written in a very similar format, okay? And you might be like, I have no idea. What would be different? This will be different. 2x minus 3y equals 6. That's different. That's not y equals something x plus something. This one is not y equals something x plus something, right? None of those are that, okay? So these that we're working with right now are called slope-intercept, and that's because this right here is going to be your slope, and this right here is going to be what we call your y-intercept. What does intercept mean? Intercept means where it goes across. Think of like intersection, right? Where it hits the y-axis, okay? So let's look at it. Ooh. We'll remove this function machine for now. If this thing in orange is my intercept, something x plus something, this is my intercept, where is it going to hit? What's my y-intercept in this equation? You might be like, what are you talking about? I'm going to show you right here. This. Okay. Do you see how this is y equals, this is going to be -1 x plus, oh, there we go, 5 right there. Now, we already graphed this. We graphed this earlier. Did we hit it at 5? 1, 2, 3, 4, 5. We sure did. Oh, that would have been easy had we known that. Okay, well, let's keep going. Does this work all the time? Well, y equals something x plus something. Do you guys see this would be -8? Plus a -8, same thing as -8. Well, let's look. Did it hit it at -8? 1, 2, 3, 4, 5, 6, 7, 8. Doggone it, it did. Okay. So if we go down to the next one, we can immediately look at this equation and be like, where is it going to hit the y-axis? Right here at 2. I know this is going to be one of the points on my line. What about this one? -6. 1, 2, 3, 4, 5, 6. I know this is going to be one of the points on my line. And you might be like, but Lorena, why? Why is this number our y-intercept? And I'll show you real quick. When a line hits the y-axis, what does the x have to be? Theoretically, a line could hit anywhere along this y-axis. It could hit anywhere. But what does the x value have to be? It has to be 0. 1, 2, 3, 4. 1, 2, 3, 4, 5. 6. It has to be 0. So if I put a 0 in for x, Stop that. What does that leave me with? Y equals -6. So when x is 0, y equals -6. That has to be a point on our line. So when it is in this format, this constant over here that's all by itself is going to be the y-intercept. Now, sometimes you have to be careful because sometimes they will try to be tricky McTrickster and they'll be like y equals -6 plus 3x. And then you might want to be like, oh, 3 is the y-intercept. Nope. It has to be in this format. Y equals something x plus something. Now, could you rewrite this? Sure you could. Y equals 3x plus a -6. Now it's in that format. And your y-intercept is going to be -6. Okay? All right, so you might be like, oh, that's fine and dandy, Lorena. I have 1 point on the line. That 1 point does not a line make. That's true. But what else is this equation called? It's called the slope intercept. So whatever number is in front of the x is going to be your slope. Yay. Okay. What number is in front of the x here? This is kind of a tricky question. I don't like to start with this one. If it were just x plus 5, we would say that was 1x, right? Not 0 x's. If it was 0 x's, it wouldn't have an x at all. That would be 1x. If it says -x plus 5, it just means -1. All right, so the slope here is going to be -1. So if I know, I'm going to erase this line. If I know that the y-intercept is 5, 1, 2, 3, 4, 5, and then the slope is -1, that's the same thing as -1/1, the rise is going to be, let me change colors, rise of 1, run of 1. Why did I go down for rise? Well, it's negative. Rise of 1, run of 1. Let me give you a hint. This line that I'm making is the exact same line that I made when I did all this work here. Super helpful. All right, so I'm going to erase all this work, and then y'all are going to help me do this. We're going to do it several times over and over again until you're like, oh yeah, I got this, no problem. Okay? First thing we're going to go through is we're going to identify the slope and the y-intercept. That's all you need to make a line. Okay? We talked about the y-intercept. We talked about how it's going to be this, right? That's going to be a -8 down here. What is our slope? Our slope is going to be whatever's in front of the x. It's going to be 2. Same thing as 2/1. A rise of 2, a run of 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. Bloop. There we go. Do we love it? I love it. We can immediately look at this equation, see where it's going to hit, and what the slope is going to do, right? Okay, let's do the next one. All I need are y-intercept and slope. All right. Circle the y-intercept. +2. Okay. So I know it needs to hit the y-axis at +2. There we go, right there. What is our slope? Oh, let's underline it. -4. Same thing as -4/1. Rise over run. Am I going up or down? I'm going down because it's -4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Oh, do we love it? I know Ty loves it because there's not a lot of showing your work. All right. Here we go. We need y-intercept and slope. All right, y-intercept, we're just going to look here. -6. Loop right there. Slope is going to be 3. Same thing as 3 over 1. Up 3 over 1. 3, 1. Bloop. 3, 1. Ah. All right, make a line. There we go. That is not too bad, right? Okay, so what I'm going to do is I'm going to run to Desmos really quick. That's what I need. And I'm going to put in some equations, and we're going to see how easy it is when it's in this format. Y equals, let's say, well, let's do a fraction. Oh, nope, not Q. 1/2 x plus 2. Okay. Now, if I were, oh, how did I do this last time? Command-Shift-4? Yeah, awesome. If I were writing on the screen, I would look at this right here. That's my y-intercept. Does it hit it too? Yeah, it does, right? What is the slope? The slope is going to be 1/2. Look right here, 1/2. That's a rise of 1 and a run of 2. Well, let's do it. 1, 2. Yes, look at that. 1, 2. 1, 2. Yes! We love it. Go away. Delete screenshot. Okay, now let's do another one. All right. If we were in class, I would have you guys give me these answers. Let's do y equals 3/5 x plus a -4. Okay. I don't like my scale here. There we go. All right. Okay, so let's move it a little bit. I can immediately look at this equation and be like, oh, it's going to hit at -4. And I put a dot right here. Yay, that's easy, right? But I can also look at the slope, which is 3 over 5, right? So my rise is going to be 3, and my run is going to be 5, okay? So if I go up 3, 1, 2, 3, I go over 5. Oh, look where it hits. Ah, right there. I go up 3, I go over 5. How convenient. I go up 3, I go over 5. These are all points that are going to fall right on the line. I can easily graph it if it is in slope-intercept form, okay? So, delete screenshot. Let's go back to Notability. If you look at your homework, Gmail, no. There we go. Okay, if we look at our homework, right, it says graphing linear equations in slope-intercept form. You're doing the exact same thing. Let's set it in Notability so I can write on it. Hopefully it'll open for me. Yes. All right, we're doing the exact same thing in our homework. Okay, it says find the slope and the y-intercept and then graph the line. Okay, so let's do slope in purple, y-intercept in orange. Okay, and if you need to color it in, right? My slope's going to be whatever's in front of the x. What number's in front of the x right here? I'll give you a hint. That's a tricky one. It's 1. And our y-intercept is going to be whatever's over here, which is 2. That means it's going to hit the y-axis at 2. And my slope is going to be 1 over 1. Oh, nope. Which means I'm going to go up 1 and over 1. Up 1. Ooh, and over 1. Ta-da! So we're doing the exact same thing that we did on our homework. Don't let the minus signs trick you. That means it's plus and negative. Don't let the fractions trick you. I think fractions are even easier. It's rise over run, right? That is every question on this lesson 116. And then we'll finish, I'll do another video for 117. There is one thing on here that I want to show you guys that I do not want to trip you up. This is what we call slope-intercept format. Every year when I introduce this, this confuses the mess out of students. But it's exactly what I've just been teaching, except for they're calling slope M, and they're calling y-intercept B. So slope-intercept form is y equals slope x plus y-intercept, which I understand sounds like a foreign language, but we will do it enough to where it won't sound like a foreign language. I said in class, I think this is the easiest way to introduce it, y equals something x plus something, right? But the first something is your slope. Mathematicians, I don't know why the abbreviation for slope is M. I really don't, but that's what it is. Y equals mx plus b. The abbreviation for y-intercept is b. Also, don't ask me. It just is. All right. I hope that wasn't too confusing for you guys. Like I said, I'm hoping to see you guys next week. No more snow, please. And I can check in with you and see how it's going.